Hello, ladies and gentlemen. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conklin, New York, and here's my email address if you want to contact me. We are starting Unit 5, continuing, because we're on the second lesson, pages 5 through 8. If you want to know the genius who wrote these worksheets, you can just scan the QR code there and listen to how he explained how to do all these. In Common Core Algebra 1, remember that we studied a particular sequence known as arithmetic, based on a constant addition to the next term. And we also studied geometric, based on a constant multiplying to get the next term. In this lesson, we're going to review the basics of these two sequences. So an arithmetic sequence is recursive, okay? So there's the direct rule and there's the recursive rule. The recursive definition, you have to be given the first number, then whatever number we're looking for is the previous number plus d. So this is previous. And the plus d, the d stands for the difference. Okay, that's going to be what we're adding on, the difference between the first term and second term and third term, and so on. So here is the second definition of it, exactly the same thing. Okay, notice the a sub n minus 1 and f of n minus 1. Where d is called the common difference, can be positive or negative. Okay, so generate the next three terms of this given arithmetic sequence. When we examine it, my first number is 2. So let's get the next three terms. So I'm going to assume that it wants, there's the first one, then we're going to have to get 4 of them. So the rule is add 6. So you take the previous number, and then add 6. Take the previous number and add 6. And then the last time, take the previous number and add 6. Any questions? I can't hear you. Oh, of course I can't hear you. Just ask me in class. A little bit of recording humor. So here we're adding a half. The first number is 3 halves. So a sub 1 is 3 halves. Now, if you remember how to add fractions, if you have a common denominator, just add the numerators. So it's 4 halves. A sub 3 is 5 halves, and a sub 4, is 6 halves. Let me correct that, 5 halves. There we go. So I just added the numerator, added 1 and the previous numerator. Exercise number 2. For some number t, the first three terms in an arithmetic sequence are 2t, 5t minus 1, and 6t plus 2. What is the numerical value of the fourth term? Hint, you first have to set up an equation that'll solve for t. Okay, this is an arithmetic sequence. What do we know about the definition of an arithmetic sequence? What makes it arithmetic? The thing that makes it arithmetic is that you have a common difference, where we're adding the same number to the equation every single time. So let me see. I am starting with 2t, and I add something, to it, and it's going to equal the next number. I wonder what the next number is. I wonder what to do anywhere in this question. Oh, there it is. It tells us what the next number is right there. So what am I going to call this blank here? I can't call it t. I'm just going to call it x. And then, that's way too big, by the way. I just wrote that way too large. So I'm going to shrink that. Now, currently, I feel compelled to manipulate this equation somehow, but why don't I write down the next equation, then you'll see maybe what's moving me in that direction. So I also know that 5t minus 1 plus something has to equal the next number. Well, the next number is 6t plus 2. What's this blank going to be? Oh, it's the same thing. It's the same x. Now, hopefully you are compelled the same way that I am to solve for x. If we add 1 to both sides, and then I'm going to subtract 5t just to save space. So we have x equaling t plus 3. And over here on the green side, I just subtract 2t. So x equals 3t minus 1. Okay, am I going anywhere? Do you know what to do next? Let me see. They both equal x. They both equal x. Equals is a very, very powerful word. It means they're the same. It means we can set them to each other. So let's set them to each other. What do I mean by that? I mean I can write 3t minus 1 equals t plus 3. Substitution. Everywhere I see an x, I can write 3t minus 1. So I saw an x right there and wrote 3t minus 1. Then I wrote down the equal sign, then the t plus 3. Quickly subtract t from both sides. I get 2t. I'm going to add 1 to both sides equals 4. Divide by 2. T is 2. Let me see. For some number t, the first 3 terms in the arithmetic sequence are those. What is the numerical value of the 4th term? Well, I know it's the first number uh, is 2 times 2, which is 4. And I know the next number is 5 times 2 minus 1, which is 9. So what's the common difference? The common difference is 5. Let's check it out again. And then 6 times 2 is 12, plus 2 is 14. So the common difference is again 5. So the next number, the 4th number, has to be 14 plus 5 is 19 because that is the common difference. So it asks what the 4th number is, first, second, third, 4th. Bingo. You have to remember not to get too deep into some problems because, you know, we could have found an equation for it and then found the 4th term. Let's just answer the question that they ask us to. It's important to be able to determine the general term of an arithmetic sequence based on the value of the index, the variable, the subscript. In other words, this is the n right there, okay, and the n minus 1. The next exercise walks you through some thinking processes that are involved. Consider a sub n equals a sub n minus 1 plus 3 with the first number a sub 1 equaling 5. Determine the next 3 numbers. Okay, so that's just it. The first number is 5, and then a sub 2, let me see, what are we doing? We're adding 3 to it, so we're just thinking about it. So that's 8, and then a sub 3 is add 3, and then a sub 4 is add 3 again. Wait a minute, why do we add 3 again? Because the rule says add 3. How many times was 3 added? Here's the thinking process. How many times was 3 added to 5 in order to produce the 4th number? Let me see. We added once, we added twice, we added 3 times. Wait a minute. To get the 4th number, we added 3 times. So here's my question to you. How many times do you add 3 to get the 20th term? Let me see. If I added it 3 times to get the 4th term, I must add it 19 times. If you don't understand, make sure you ask me in class. Use your results from part B to quickly find the value of the 50th term. Okay, it seems like that we're going to be using n minus 1. And so n here is 50. So we're going to do 50 minus 1, which is 49. That's how many times we're going to add 3. So it's 49 times 3 plus the original number. The original number was 5. So this is 147 plus 3. Plus 5. To get 152. Write a formula for the nth term of an arithmetic sequence, a sub n, based on the first term, a sub 1, d, and n. Okay, so we were compiling that. We're bringing it together here. So it looks like that we're going to have an n minus 1. Remember, because we take the number of terms minus 1. And then, let me see, what did I do? I multiplied it by the difference. And then I also had to add, oh, that's going to be the difference, sorry. It's going to be a D, not a 3. And then I also had to add the first term. And that equals a sub n. Write that a little neater. A sub n equals D times n minus 1 plus the first term. That is the direct rule. Or the direct formula. Stop here for a second. Let's see what's on the next page. Exercise number 4. Given that a sub 1 is 6 and a sub 4 is 18, they're members of the same arithmetic sequence. Determine the values of a sub 20. Okay, do we have our thinking caps on? Do we have the first number? Yes, it gives us the first number. Do we have the next number? No. Do we have the rule? No. Okay. 6 is the first number. Second, third, fourth. The fourth number is 18. Arithmetic sequence. Arithmetic sequence. You have to do something. What do we have to do? We have to add or a common difference. So when we're thinking about arithmetic sequences, we always think common difference. Geometric sequences, we're going to think about something else. So how many times do I add something? It's going to be 6 plus x. 6 plus x is going to equal that number. And then this number plus another x is going to equal that number. Plus another x is going to equal that number. So let me see. I added once. I added twice. I added 3 times. So let me see. 6 plus 3x has to equal 18. How about that? We just fell into an equation by thinking. 3x is 12. Divide by 3. X is 4. Determine the value of the 20th term. We can write them all out. However, we just derived the formula. A sub 20 equals the difference, and then n minus 1 plus a sub 1. So a of 20 equals, what was the difference? The difference is 4, right? That's what we found out. Yeah, difference is 4. N is 20, so it's going to be 20 minus 1. How do I know n is 20? Because it's the 20th term that we're trying to find. A sub 1, what's the first number? 6, so we add 6 to it. This is 80 minus 4, which is 76. So a sub 20 is 76 plus 6, which is 82. Did we answer the question? We did. Find the value of a sub 20. Let's carry on with geometric sequences. Geometric sequences are defined very similar to arithmetic, but with a multiplicative constant. ding, 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 instead of an additive one. So here we have my number is the previous number times whatever that ratio is. That's why it's R. Okay. Uh, Now, generate the next three terms of this geometric sequence. Okay, so the next three. So a sub 1, a sub 2, a sub 3, and a sub 4. A sub 1 is 4, and the ratio is 2. So this is 4 times 2, which is 8. And then this is 8 times 2, because that's the ratio, is 16. And then the fourth number is 16 times 2, which is 32. So those are the four terms. This next one says we're going to take 1/3 of it. Okay, there's the ratio right there. So we're going to start with 9. That's the first term. And then the next term is 9 times 1/3. 1/3 of 9 is 3. And then we're going to take 3 times 1/3. You can use your calculator if you need to, but it is 1. So first term, second term, third term, one more. 1 times 1/3, 1 times anything is itself. So there's the fourth term. This one is sweet. Our constant is an irrational number, square root of 2. Fortuitously, we're starting with a square root of 2. 3 square root of 2 times the square root of 2. This is the second term. So let me see. The first term is 3 square root of 2. Now, square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Yeah, I'm just slowing down the thinking process so you're thinking along with me. So this is 3 times 2, which is 6. This is tying and untying the shoelaces, so we just get a 2 there. 6 times the square root of 2 is just 6 square root of 2. It's irrational. And then the next number is 6 square root of 2 times the square root of 2. That seems like 6 times 2, which is 12. So we have the second number, the third number, and the fourth number. There they are. And like any arithmetic sequence, we need to be able to determine any given term of a geometric sequence based on the first value, the common ratio, and the index. The n, or the n minus 1, is the index. So we're going to walk us through and find a formula just like we did with arithmetic for the direct rule. So here we have a common ratio of 3, and our starting number is 2. So it says just find the value of a sub 4. So we have 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And this is a sub 4. How many times do you need to multiply 2 times 3 in order to find a sub 4? That 3 really has nothing to do with it. We could have been multiplying it by 7 or by 23. Let me see, we multiplied it once, we multiplied it twice, we multiplied it 3 times. To get the fourth term, we had to multiply it 3 times. Well, what about the 10th term? Any speculation? I'll bet you it's 9 times. Okay, so it looks like determine, oh, there it is, the value of a sub 10. I'm sorry about that. No wonder why 10 was prominently in my mind. So let's go ahead and do it. So the first number was 2, and then the second number multiplied by 3, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. 39,366. Hang on here a second. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There must have been an easier way to do repetitive multiplication other than writing it down. Repetitive multiplication. Oh, there it is. 2 times 3 exponent 9. Hmm, looks like we're finding a formula here. Write a formula for the nth term of a geometric sequence a sub n based on the first term and the ratio and n. Drum roll, please. The formula we are still going to use a sub n, like it said, because we're trying to find the nth term of a series. And we're going to start with, we have to know what the first number is, always given, the ratio, which is the r number, and the exponent is going to be n minus 1. This is it for the day. If you have any questions, make sure you ask me in class. Your next 2 pages are homework. Thank you. Mr. Bryce, signing out.